Hello, everybody. Welcome to another Gazebo community meeting. And let me start by sharing the screen as usual. This is the plan for today. We'll start with the Gazebo announcements, and Addisu will go over the round of news. And then our invited talk today is from Yasuhiro Yoshiumura, who was nice enough to talk about a tool he created called mesh2gazebo. We'll go over the details later. And then, as usual, we'll have plenty of time for questions. So let's start. Addisu, are you ready?
Yeah, thanks, Carlos.
Thank you.
This month, we have a few features that I'd like to highlight. The first one is for the auto inertia feature that was released with Harmonic. We now, in the past, it used to require you to specify the density of a collision, but now you can just specify the mass of a link, and it would figure out the moment of inertia for you. And so this makes it a lot easier to use, and in most situations you can actually measure the mass of the weight of the object that you're interested in if you're making a robot, for example. But figuring out the density is a bit harder. So this just makes it a lot easier to use. So this has been merged. The next one is we have a new feature to visualize the frustum of logical cameras. If you click on the issue there, you should see a picture of what that looks like. This was contributed by Karsh. I apologize if I'm saying your name, pronouncing your name wrong. But shout out to you for doing that. Really appreciate it. It creates this frustum shape in front of the sensor to show you what is being covered by the sensor. And we also have an issue for extending this to regular camera sensors. So as I said, the one that was merged was for logical cameras, which basically what logical cameras do is they look like cameras, but they just report the poses of the objects within the view of the sensor. So we'd like for this to be extended to regular cameras. So if you are interested in contributing, this would be a great issue to tackle. And then the next one is we have the array intersection feature merged. This one allows you to request for ray intersections from the physics engine. You create a component to say, the ray, generate rays from this object going in many different directions. And then after one physics iteration, you get back all the intersections of that ray going out into the scene. So this was also contributed by, I should have put their name on the, Romo Garcia, Romulo. Thank you for the contribution. Shout out to you. And in the future, we hope to use this to create CPU-based LiDAR sensors. But this feature is currently available. If you want to use it in your own plugins, you can easily get ray intersections. Last but not least, we have our Conda migration of our Windows CI complete. So our Windows CI now uses Conda/Pixie for running all of our Windows builds, which means that all of the user instructions for installing Gazebo on Windows is also being used by the team and by our CI. So we will know if something is not working there. It's easy for us to catch it. And so there's symmetry in that. So this is great, and we're happy to announce that, and hopefully make more progress on getting Windows working better for everyone. And that's it for me.
Thank you, Addisu. All right, so now we can transition to the next item in the agenda, which is our invited talk. So I'd like to introduce Yasuhiro Yoshiumura from CyberAgent. Special thanks for accommodating this time. I think it's late over there. And Yasuhiro is going to talk about a tool he contributed called mesh2gazebo, and he will go over all the details. But it's I guess I'll describe the wish that he mentioned. Like, I want to build a simulator environment by simply taking photos of the environment with my smartphone. I think it's a nice thing to have. So looking forward to I guess hear about all these details. Yasuhiro, are you ready?
Yes.
Okay. You can start when you're ready. All yours.
I share screen, my screen. あれこれか
That works.
Yes. I have presentation about mesh2gazebo. Mesh2gazebo is tool to build simulator environment using mesh data of 3D scan application. I introduce myself. My name is Yasuhiro Yoshimura. I work at CyberAgent. CyberAgent is Japanese digital advertising company. I research robotics and sensing to understand real environment. And I published book for the developer of OpenCV. This slide explains about motivation to develop this tool. I hope to quickly build simulator environment to develop software for autonomous robot. I hope build simulator environment by simply step with my smartphone. So I capture real world using my smartphone. As a result, realistic Gazebo world is generated. I developed a previous work named Point Cloud to Gazebo. This tool has the following problem. The quality of mesh data is not good, and mesh data does not have color information. And this tool support only Gazebo Classic. Gazebo Classic is end of life tools. So I developed latest tool is mesh2gazebo. And this tool solves this problem. The quality of mesh data is good. Mesh data has color information. This tool support Gazebo ignition. Left image is real world in-store environment. Center figure is 3D mesh data of in-store environment. So I convert this mesh data to Gazebo world. So I propose a mesh2gazebo by the following steps. At first, I scan real world using 3D scan application. This application can export mesh data, object format, and texture. So mesh2gazebo convert this mesh data, mesh2gazebo convert from mesh data to Gazebo world. So developer can use photometric mesh data in Gazebo simulator. Please see this movie. こっち動画に、こっちになってないのか。I shared my movie. At first, this movie shows a real in-store environment. And in this video shows generated Gazebo world using mesh2gazebo. And I launched navigation tool in Gazebo world. Left window shows camera images in Gazebo world. So user can develop software in this environment. で、止めて、共有して、This is appendix page. I visualize of mesh data in RViz2. Left Windows RGB camera. Red point is scan, 2D scan data. I can visualize a cost map on this mesh data. I explain system information. This time I checked the following environment. I use Yasuhiro Taddese and I use Gazebo Harmonic. I use Scaniverse as 3D scanner application. This is iOS application. Next, I explain technical briefing of this tool. At first, I explain 3D scanning. This time, I use Scaniverse for 3D scanning. And I scan floor as well for post-processing. And I export object format. Next step, I convert DAE format. I convert from object format to DAE format. In this conversion, I use mesh lab. Left figure shows exported mesh data. Right figure is exported texture data. In this slide, I explain about post-processing. Scan result. If there is a difference between Gazebo and mesh and coordinate, I need to rotate. So I use the mesh lab to rotate mesh data. Mesh lab has this menu, normal commercial orientation. So I use I specify transform rotate to rotate mesh radar. And rows of captured from in capture from Scaniverse. Sometimes the floor surface is not flat because there is error data. So I adjust the height of mesh data. Left figure is before images. This floor surface is not flat. So I adjust the height of mesh data. As a result, floor surface is flat. Next step is making of SDF file as Gazebo world. So previous step, make mesh data. So I specify the file path of mesh data in collision tag in SDF file. And I specify file path of mesh data in visual tag in SDF file. This slide explains my future works. I published a repository of mesh2gazebo. This repository has a template data of Gazebo world using mesh data. And next, this slide, appendix slide. High quality mesh data has many mesh polygon data. So CPU usage make high. So I disabled cast shadow parameter to decrease CPU usage. So I set cast shadow to 0. And I use in this time I use in-store data, real in-store data. So this place is Ezo Hub Tokyo. So the in-store image is created as Ezo Hub Tokyo with the cooperation of Satsudora Holdings. Satsudora Holding is drugstore. My presentation finished. Thank you.
Thank you. Thanks a lot, Yasuhiro. That was a great to hear about your, I guess, your pipeline for creating the world. I think we have time for questions. Any question for Yasuhiro? I can start with, I was going to ask you at the beginning about which phone application you used to scan, but you mentioned during the presentation that it's called Scaniverse, right?
Yes.
So how reliable is that application? Like how happy you are with the results? Like, does it create holes, or in general it's reliable?
I think Scaniverse cannot なんだろ 細い。narrow Canvas cannot make mesh data for thin image. なんだろう。ちょっとPlease wait a little.
So let's say I'm not entirely sure if I catch it, but let's say like from 1 to 10, how happy are you with Scaniverse? Is it like relatively okay or?
Sorry. Please, your question. Please write your question in
Sure.
text data.
Yeah. So I'm gonna write it in the chat. How I guess happy are you with the behavior of Scaniverse? So just curious to see if Scaniverse is reliable or you had to try multiple times or.
I'm generally satisfied, but sometimes a thin object, for example, pole, Canvas cannot capture.
I see. I think you mentioned that it has problems with shadows and things like that. Okay. I think my other question was related with the post-processing steps that you mentioned. At the beginning, I was not fully understanding the process, but I think my understanding of what you're doing is that with MeshLab, you're adjusting the origin in the Z axis to make sure that it's always above the floor in a way that when you create the gazebo world, the ground plane is always on top of that
Yes.
surface, right? Is that correct?
Yes.
Okay, I understand. Any other question for Yasuhiro? I think there's. Oh, Ian, please go ahead.
I think someone typed in chat first, so they can go.
Yeah. So it's a question from Diego. You can see it on the chat, Yasuhiro. But essentially,
Yes.
oh, so
I checked the correctness of length of mesh. I use iPhone Pro. iPhone Pro has LiDAR sensor, so accurate is very good.
okay. Did you verify? Did you measure or did you make any verification or just to double check that it was?
Yes.
Okay, sounds Sounds like you did.
In Scaniverse, mesh data, in Scaniverse, user check two the length between 2 points, and I measured length, real length, and I check there is no problem.
Okay. Ian?
Yeah, thanks for the presentation. You mentioned that you have issue with rendering, yeah, you have to disable shadows. I think I haven't used Scaniverse before, but usually the raw point cloud you get, you have many points, so you end up with a lot of triangles. Have you tried like reducing the number of vertices in the DAE mesh as a post-processing step to help?
I have mesh data, so I show this mesh polygon data. So please wait a little. Good. Can you see mesh labos window?
Yes. We can see it.
Can you see triangle mesh?
Yeah, it's very dense.
Yes.
There are a lot of triangles in there.
Is it possible to adjust the resolution or the number of triangles from Scaniverse? Or
Yes. This tool has feature to decrease mesh data.
yeah, so I guess I'm not sure if Scaniverse can do it, but the other option is reduce it in MeshLab, perhaps.
But I didn't decrease mesh data for simplify in this time because mesh in this tool can decrease mesh number of triangle, but texture data cannot change, so visualization is not good. So I didn't do simplify.
And I'm not sure. Yeah, I'm not sure if you need shadows for something that's like all the shadows already captured in the texture here. So I think it makes sense to turn off shadows.
Okay. Any other question, Ian?
No, looks good, because I think that there are a lot of individual small items on the shelves, and you're gonna have a nice quality rendering. You cannot reduce the vertices. I guess that's why.
Yeah, maybe only for the collision. Any other question for our guest? All right. Thanks again, Yasuhiro. Thanks for joining the. Oh, Steve.
I clicked the wrong button. I was trying to clap, make a clap emoji. So.
All right. Thanks for joining, Yasuhiro, and for sharing your project and your ideas. Looking forward for the next iteration, as usual.
Yes, thank you for invitation of this meeting.
Of course. And we can finish early, or if anybody have also any other question, any other topic, any other idea who wants to bring, please feel free to share it.
Sorry, I had a problem with my microphone. Just an observation on the what you said about the collision and not the visual part. I kind of saw that the information, like visual information, wasn't coded directly in the triangles, but in the in images projected in each triangle in the mesh. So maybe if you are only concerned about the collision geometry of the mesh and not the visual part, just reducing the mesh to less triangles would keep an attractive appearance while being practical for the geometric part.
Okay. Thanks a lot, Diego. Do you have any other comment, Diego, now that you're here, or question?
No,
I posted URL of X. The recently our work and this robot do navigation real world in store environment.
Okay. Yeah, that looks nice. All right. Any other comment or question before we wrap up?
I have a question, but it's not about this discussion, so I wanted to wait until this topic ended. It's about the new Gazebo. I'm doing migration of features from Classic to Harmonic, and something that I have not been able to solve is getting an instance of a sensor in the way that it was being done, or it was possible to be done in Gazebo Classic, which using the Gazebo sensor manager, you could get a pointer, a dynamic pointer to a sensor instance, and from there get the readings from that sensor. I have not been able to accomplish the same thing using the entity component manager. And I don't know if there is some example that I could look at or some class that you can point me to.
So we have systems that store the sensors, and then they will write the data. Well, historically, most of our sensors have just been publishing the data on GZ transport topics. We recently updated the force torque sensor so that it writes its data directly to the ECM. but yeah, as you say, there isn't currently a way to get a pointer to the GZ sensors object. I think we would have to, yeah, currently those objects are owned by the whatever system is responsible for that sensor type. I think
Oh, okay.
I believe all the rendering sensors are in a system called sensors, which is not the most clear name, but the other sensors like that don't require rendering, like IMU, air pressure, force torque. I believe there's like a distinct system for each one. I don't know if we have a way to extend those systems unless you like wrote your own custom system. I don't know what any of the other maintainers, if they have any better ideas.
This is not directly answering your question, but I was gonna point you to this example in GZSIM, which is the implementation of this sensor called DVL, and it goes side by side with this another pull request in GC sensors. So this is an example of creating a sensor with a custom rendering, and it's a relatively complicated sensor. So perhaps there are similarities with what you're trying to do. You can use it as an example.
Okay. Yeah, I'll take a look. So, no, unfortunately, I cannot share it. I could make a small example, but the idea was that, or the reasoning behind is that we were not using a Gazebo plugin that was linked to the sensor. So we had like the sensor and then a system that Gazebo Classic was connecting to the sensor entity directly, because of where the processing was being done. So we wanted to like get that information without creating a plugin in Gazebo. That was the reason behind it. But yeah, I will take a look at these examples, and yeah, I actually know Mitch, so I can also reach out to him about this work that he did.
Just curious, why do you need the sensor pointer? Can you just get the data from the topic, or do you need the sensor pointer to get more information other than the data it produces?
No, it's about the information itself, but we wanted to like replicate it. The first approach was replicating what was possible in Gazebo Classic, but if all the information is all the information from the sensors available in the transport topics?
Depends on what information you're looking for. If it's like, for example, camera image, you get it from topic. If it's camera intrinsics, there's a separate topic for that. But
Okay.
it really depends on what the sensor and what data.
Okay. Yeah, then I'll take a look at that as well. But to be honest, it's like a mix of trying to replicate what was being done in Gazebo Classic and not fully understanding what entities are at hand in the new Gazebo. So yeah. I will take a look at these links that you shared, and in any case, then I can also ask again in the Gazebo forum. Thank you
Thanks
for time.
Any other comment, question? Maybe it's on.
Hello there. I recently have been working on the migration of some plugins from Gazebo Classic to Harmonic, and just face an issue with the LiDAR and the engine render engine. Sorry, let me show you a short video about it. Sorry. Let me move this here. Sorry. Third screen. Did you see something?
Yes, we can see it.
So basically, the rays are crossing the floor when using Overlay 2, but this is solved using the previous version. Here, basically, the LiDAR is a little bit pitched. The feedback of the LiDAR is just a noisy laser scan message. I'm not sure if you guys have facing this issue, or maybe there's a work around the migration to the CPU LiDAR.
I'm sorry, I don't. Can you show the video again?
Sure. Sorry.
Yeah,
Give me a second.
I'm trying to understand what the issue is.
Look at this. This is the top view of the LiDAR. Just a plane and the LiDAR. The LiDAR is a little bit pitched. So if you look here, the LiDAR is crossing the floor.
Okay.
If you check this in Arbis, the point load is just a mess. It's just noise in this point.
Okay, can you create a ticket? And I can respond there.
Yeah, sure.
Okay, thanks.
Yeah, we
Is the LiDAR supposed to be
the LiDAR. Yeah, sorry, I'll unmute because Davidson's been working on this with us in part of the migration stuff. And this just came up on Friday, so we tried to rip it out of our thing and make a reproducible example and file a ticket. But because it came up, like, it works, but now that we're testing it a little bit more, we're realizing there's all kinds of other problems with it, like the noise, and we're seeing that when there's an intersection of the plane of the LiDAR with the plane of the floor, and the LiDARs are tilted a little bit, so they're actually tilted up for safety reasons. Most LiDARs are, but because they're tilted up, the backwards part of the LiDAR is going to intersect with the floor because that tilts down. Yeah, so this is just like late breaking thing, and we just trying to rip all of our internal stuff out to make a reproducible thing for the public side, and that's why we didn't have that ticket ready.
okay? So just to understand, it's probably LiDAR intersecting with a plane not working properly.
Yeah, LiDARs intersecting with planes seem to not give a straight line.
Okay.
And it looks like they're going through. Looks like they're going through the floor.
Okay.
In weird ways.
Okay.
Also,
go ahead. Sorry.
Also, like the noise when the LiDAR does hit things, that is much different than the original ones. But we had custom noise models anyway, so we're still trying to debug what the differences there are. But there's definitely a few threads we're all pulling out on these LiDARs as we start to use it more.
And have you guys tried using Ogre 1 as the sensor mode or whatever, rendering engine?
I'll let Davidson answer that one because he did.
Yeah, actually, sorry, Alex. Actually, that solved the problem. So the main issue here is Ogre 2.
Okay.
Yeah, I think there are a couple of tickets recently about the accuracy of LiDAR.
We hit it, and then within a few hours, we saw that somebody else had hit it, and then there's a lot of like ongoing things. And I think it's as end of life stuff, people start to actually do the migration. It worked before, but now that we're really doing the testing and seeing it, it's like there are a lot of issues with the LiDAR.
All right. I guess we'll take a look offline at that one. Any other comments? Questions? All right. I guess we can leave it here then. Thanks everybody for tuning in. We'll see each other next month, and as usual, we'll publish the video of the meeting in Vimeo. And thanks everybody for attending. See you next time.
Bye.
Ciao, ciao.
Thanks.